The reinforced concrete rises from the arid terrain like a modern monument to national security, stretching toward the horizon in a continuous, unbroken line. What we're witnessing isn't merely construction, it's the physical manifestation of a complex geopolitical strategy that has evolved across multiple administrations and reached new momentum under President Trump's 2025 Border Security Initiative. Welcome to our comprehensive analysis of the United States border barrier system, a massive infrastructure project with profound implications for national security, immigration policy, and international relations. Today, we're going to examine the technical specifications, strategic objectives, and operational capabilities of this evolving security architecture. The current expansion phase represents a significant acceleration in barrier deployment capabilities. The $70 million contract recently awarded to Granite Construction Corp. Has initiated construction of approximately 7 miles of new barrier near McAllen, Texas, a critical sector in the Rio Grande Valley that has historically experienced high volumes of unauthorized crossings. This segment serves as the vanguard for a larger construction mobilization along the 1,954-mile southern border. The modern border barrier system bears little resemblance to the rudimentary fencing of previous decades. Current specifications call for steel bollard barriers reaching 18 to 30 feet in height, embedded in concrete foundations extending 6 feet below ground level to prevent tunneling. These aren't simple fences. They're sophisticated security installations engineered to withstand breaching attempts while facilitating surveillance and rapid response. The bollard design allows Border Patrol agents to maintain visual awareness of activity on the opposite side while presenting a formidable physical obstacle. The steel components are filled with concrete for additional structural integrity, and anti-climbing plates cap the uppermost sections. Engineers have developed specific modifications for varied terrain conditions, from desert flatlands to mountainous regions and riverine environments. What makes the current construction initiative particularly noteworthy is its integration with advanced surveillance technology. The physical barrier serves as just one element in a layered defense system that includes ground sensors, radar installations, and aerostats, providing persistent aerial surveillance. Fixed camera towers equipped with infrared and electro-optical sensors create a comprehensive detection grid that dramatically extends the operational awareness of border security forces. The presidential authorization of April 11, 2025, represents a strategic escalation in border security operations, granting the U.S. military control over the Roosevelt Reservation, a 60-foot-wide federal land strip running along the border in California, Arizona, and New Mexico. This directive has transformed the operational dynamics of barrier construction and enforcement, establishing a military presence directly engaged in border security infrastructure development. Military engineering units bring specialized capabilities that accelerate construction timeframes and overcome technical challenges previously facing civilian contractors. The Army Corps of Engineers has deployed specialized equipment capable of operating in extreme terrain conditions, including modified excavators, mobile concrete batch plants, and rapidly deployable bridging assets that facilitate construction in otherwise inaccessible areas. The operational tempo of construction has increased dramatically under this new paradigm. Military logistics chains and resource allocation protocols have streamlined material delivery, while specialized engineering units work in continuous shifts to maintain 24-hour construction operations in priority sectors. This approach has reduced projected completion timelines by approximately 40% in initial deployment zones. The technical specifications of the barrier system continue to evolve based on field performance data and emerging threat assessments. Recent modifications include enhanced sensor integration points built directly into barrier segments, allowing for modular installation of monitoring equipment without compromising structural integrity. Anti-digging measures have been extended to greater depths in areas where geological assessments indicate vulnerability to tunneling operations. What many observers fail to appreciate is the complexity of the site preparation required for effective barrier deployment. Construction teams conduct extensive geological surveys to identify subsurface conditions that might compromise barrier stability or create vulnerabilities. In areas with shifting sand dunes or unstable soil conditions, specialized foundation systems must be implemented to ensure long-term structural integrity. The McAllen sector construction illustrates this technical complexity. Integrity. These specialized adaptations reflect the complex balance between security requirements and environmental stewardship. From a broader strategic perspective, the border barrier system represents just one component of a comprehensive national security architecture. Its effectiveness depends on integration with other elements, including interior enforcement operations, legal framework modifications, and international cooperation agreements. The Lake and Riley Act, signed into law on January 29, 2025, strengthens this framework by mandating detention of illegal immigrants charged with specific offenses and empowering states to hold federal agencies accountable for enforcement lapses. Construction. Teams operate under unique security protocols during barrier installation. Active work sites represent potential targets, requiring dedicated security elements to maintain perimeter control during construction operations. Military personnel provide overwatch capabilities, employing advanced surveillance systems to detect potential threats before they can impact construction activities. This security envelope ensures continuous construction progress even in high-threat environments. The technical challenges of barrier construction vary dramatically across different geographic regions. In the rugged mountainous terrain of eastern Arizona, construction teams employ specialized equipment designed for operation on extreme gradients. Modified excavators with enhanced stabilization systems can operate on slopes up to 40 degrees, allowing barrier installation across previously inaccessible terrain features. These specialized capabilities have eliminated many of the geographic gaps that previously compromised border security effectiveness. Water management presents particular challenges in riverine environments. Barrier segments near the Rio Grande must accommodate seasonal water level fluctuations while maintaining security integrity. Engineers have developed modular barrier systems that can be rapidly reconfigured during flood events, preventing structural damage while maintaining continuous security coverage. These adaptive systems represent significant advancements over previous static barrier designs. The construction timeline reflects both strategic prioritization and resource availability. High-priority sectors have been designated for accelerated completion, with construction resources concentrated to achieve rapid security enhancement in the most vulnerable areas. This approach creates a progressive hardening effect, systematically eliminating the most exploitable crossing corridors and forcing potential crossers toward increasingly difficult terrain where interdiction becomes more effective. The operational concept for the completed barrier system involves a sophisticated integration of physical infrastructure and surveillance technology. Fixed surveillance towers positioned at strategic intervals provide continuous monitoring capability, with overlapping coverage zones eliminating blind spots. These systems employ multiple sensor types, including ground radar, infrared cameras, and traditional optical systems, creating a detection capability that functions under all weather conditions and lighting situations. The barrier systems. Effectiveness becomes particularly apparent in statistical analysis of crossing patterns. March 2025 reported approximately 7,200 migrant encounters, representing a dramatic decline from over 189,000 the previous year. This reduction correlates directly with the progressive implementation of the enhanced barrier system and associated enforcement measures. The numbers tell a compelling story of operational effectiveness that transcends political rhetoric. Military involvement has introduced advanced construction methodologies previously unavailable to civilian contractors. Rapid Deployment Bridge. Sections, originally designed for combat engineering operations, have been repurposed to facilitate barrier construction across drainage channels and small waterways. These prefabricated components can be installed in hours rather than days, dramatically accelerating construction timelines in complex terrain. The barrier's physical presence creates what security analysts describe as a channeling effect, forcing crossing attempts toward monitored gaps where interdiction becomes more efficient. This operational concept leverages the psychological impact of visible security infrastructure to influence decision-making among potential crossers, creating predictable movement patterns that can be effectively monitored with limited personnel. Resources. Communication systems embedded within the barrier framework create a networked security environment that extends far beyond the physical structure itself. Fiber optic cables running through barrier foundations provide high bandwidth data transmission capabilities, linking surveillance systems, ground sensors, and response forces in a unified information environment. This connectivity transforms the static barrier into an intelligent security system capable of coordinating rapid response to detected incursions. The current construction initiative benefits from technological advancements that weren't available during previous barrier deployment efforts. Modern ground-penetrating radar allows construction teams to identify subterranean vulnerabilities before they can be exploited, while advanced material science has produced concrete mixtures specifically engineered for the environmental conditions of the border region. These technical advantages translate into more effective and durable barrier systems than were previously possible. Specialized engineering units have developed innovative solutions for particularly challenging terrain features. In areas where traditional foundation systems prove impractical, micropile technology creates deep structural anchoring without requiring extensive excavation. These systems can be installed with minimal environmental disruption while providing superior stability in unstable soil conditions. Such specialized approaches have eliminated many of the geographic constraints that limited previous barrier deployment efforts. The comprehensive nature of the current security strategy extends to aerial surveillance capabilities that complement the physical barrier. The deployment of aerostats, tethered surveillance platforms that provide persistent observation capability, creates awareness zones extending miles beyond the physical barrier. These systems employ sophisticated sensor packages capable of detecting and tracking movement across vast areas, providing early warning of potential crossing attempts before they reach the physical barrier. From a broader strategic perspective, the Barrier Construction Initiative represents a tangible commitment to territorial security that influences international dynamics beyond its physical presence. The visible progression of construction activities sends a clear message regarding enforcement priorities, potentially influencing migration decisions before individuals even reach the border region. This deterrent effect amplifies the barrier's physical impact through psychological and informational channels. Construction scheduling reflects seasonal considerations that impact both efficiency and effectiveness. In desert regions, summer temperature extremes create hazardous working conditions and affect material performance. Construction resources shift to more moderate climate zones during extreme temperature periods, maintaining continuous progress across the project timeline while adapting to environmental limitations. This flexible scheduling approach optimizes both personnel safety and construction quality. The barrier's design incorporates lessons learned from global border security operations. Israeli security barrier features have influenced specific elements of the bollard system, while surveillance integration concepts draw on European border management experiences. This knowledge transfer ensures that the U.S. border barrier benefits from proven security concepts while adapting them to the specific requirements of the southern border environment. Military control of the Roosevelt Reservation has transformed the operational security environment surrounding construction activities. Forward operating bases established at strategic intervals provide secure staging areas for both construction materials and security personnel. These installations function as force projection platforms, extending security presence beyond the immediate construction zone and creating buffer areas that protect ongoing operations. The barrier system's effectiveness ultimately depends on its integration with broader enforcement initiatives. The reinstatement of the Remain in Mexico policy creates complementary pressure on immigration patterns, while expanded detention capabilities facilitate processing of interdicted individuals. The designation of criminal cartels as foreign terrorist organizations provides additional legal frameworks for enforcement operations, creating a comprehensive security approach that extends far beyond the physical barrier itself. As construction continues across priority sectors, engineers constantly evaluate performance data to refine barrier specifications. Field reports regarding breach attempts inform ongoing design modifications, creating an adaptive security system that evolves in response to changing tactics. This iterative improvement process ensures that the barrier system maintains its effectiveness, despite evolving challenges. Construction teams operate with remarkable efficiency despite the project's massive scale. Military engineering units work in coordinated shifts, maintaining continuous operations in high-priority areas. Mobile concrete. Plants deployed near construction sites eliminate transportation delays, while prefabricated barrier components. Initial site preparation involved removing dense vegetation and unstable topsoil before establishing a compacted foundation layer capable of supporting the massive weight of the barrier system. Drainage systems were engineered to prevent erosion during seasonal flooding, while still maintaining the security integrity of the installation. These aren't simple construction projects. They're sophisticated engineering operations tailored to specific environmental conditions. The barrier system must contend with diverse geological and environmental challenges across its length. In Arizona's Sonoran Desert, construction teams face extreme temperature fluctuations that affect concrete curing times and material expansion rates. Specialized concrete mixtures with modified setting agents have been developed to maintain structural integrity in these conditions. In mountainous regions, engineers employ dynamic anchoring systems that secure barrier foundations to bedrock, preventing displacement during seismic events or extreme weather. From a tactical perspective, the barrier system creates what military strategists refer to as a force multiplier, significantly enhancing the effectiveness of limited personnel resources. Each completed section reduces the area requiring direct surveillance, allowing Border Patrol agents to concentrate on strategic crossing points and respond more rapidly to detected incursions. The physical obstacle increases crossing times from seconds to minutes or hours, creating adequate response windows for interdiction teams. The integration of military assets into border security operations represents a significant shift in operational doctrine. Military surveillance platforms, including aerostats and unmanned aerial systems, provide persistent observation capabilities that civilian agencies previously lacked. These systems feed into a unified command and control network that coordinates responses between military personnel and Border Patrol agents, creating a seamless security envelope. Construction logistics present their own strategic challenges. The remote locations of many barrier segments require establishment of temporary forward operating bases to house construction personnel and equipment. These bases function as miniature military installations, complete with security perimeters, power generation capabilities, and supply chains that must be maintained across difficult terrain. Military logistics experts have implemented aerial resupply operations in particularly isolated sections, using helicopter deliveries to maintain construction momentum. The comprehensive nature of the current border security strategy extends beyond physical barriers. Executive Order 14159, titled Protecting the American People Against Invasion, established a multi-layered approach that includes expanded expedited removal processes, increased hiring of ICE and CBP agents, and enhanced federal prosecutions for immigration-related offenses. The physical barrier serves as the visible component of this broader strategic initiative. The construction process itself follows a prioritization matrix based on detailed threat assessments and crossing pattern analysis. High-traffic corridors receive immediate attention, with construction resources allocated based on a combination of historical crossing data, terrain accessibility, and proximity to urban areas. This data-driven approach ensures that limited resources achieve maximum security impact, creating a progressive hardening of the border from most vulnerable to least vulnerable sectors. Materials procurement represents another complex dimension of this massive infrastructure project. The quantity of steel and concrete required for full implementation exceeds the production capacity of many regional suppliers, necessitating coordinated deliveries from manufacturing centers across the country. Military logistics experts have established dedicated supply chains that bypass traditional commercial distribution networks, ensuring priority delivery to construction sites regardless of commercial market conditions. The barrier's design has evolved through an iterative process incorporating field performance data. Early prototypes underwent systematic penetration testing, with specialized teams attempting to breach, scale, or tunnel under different configurations. These empirical results informed design modifications that addressed identified vulnerabilities. The current bollard system emerged as the optimal balance between structural integrity, visibility requirements, and resistance to breaching attempts. Environmental considerations have necessitated specific adaptations in sensitive ecological areas. Wildlife migration corridors incorporate modified barrier segments that prevent human crossing while allowing passage of indigenous species. Drainage systems are engineered to maintain natural watershed patterns, preventing ecological disruption while maintaining security. Streamline installation processes. This operational efficiency translates into rapid security enhancement across vulnerable border sectors. The comprehensive border security strategy implemented in 2025 represents a multi-dimensional approach to territorial integrity that extends far beyond simple physical barriers. By integrating advanced technology, leveraging military capabilities, and implementing complementary policy measures, this initiative has created a sophisticated security architecture that dramatically reduces unauthorized crossings while facilitating legitimate cross-border activities. The physical barrier stands as the visible manifestation of this broader strategic commitment, a concrete expression of national sovereignty in an increasingly complex security environment.